This video will cover the topic, translating the graph of a function, 2 steps. When translating or shifting a graph of a function, each point on the graph must be translated or shifted the same direction and distance.
How do we know what distance and direction to shift the graph?
Good question. Graphs can be translated horizontally and/or vertically, and we can tell which direction and what amount to shift the graph based on what is being done to the function. Here's what the rules look like in general, treating the variables f and g as functions and a and b as positive real numbers. The following rules cover horizontal translations of the equation y equals g of x. When graphing the equation of y equals g of x plus b, we must shift the graph of the equation y equals g of x left the amount of b units. When graphing the equation y equals g of x minus b, we must shift the graph of the equation y equals g of x right the amount of b units. That covers cases of horizontal translations. Now on to vertical translations. These rules cover vertical translations of the equation y equals f of x. When graphing the equation y equals f of x plus a, we must shift the graph of the equation y equals f of x up the amount of a units. When graphing the equation of y equals f of x minus a, we must shift the graph of the equation y equals f of x down the amount of a units.
Okay, I think I get it. Can we look at an example problem now?
Say we have the graph of y equals 4 to the power of x, and we are instructed to translate the graph so it will become y equals 4 to the power of x plus 2 plus 1. First, let's start by identifying what kind of translations we are going to make to this graph. Looking at the translated equation, y equals 4 to the power of x plus 2 plus 1, we can see that there are two operations acting on the original equation, y equals 4 to the power of x. 2 is added to the x, and 1 is being added to the function as a whole. Based on the vertical and horizontal translation rules we just covered, what is the direction and distance of the translation we are going to apply to the original graph of y equals 4 to the power of x?
If I remember our rules for identifying vertical and horizontal translations correctly, we can identify that adding 2 to the x inside of the function is going to result in a horizontal translation 2 units to the left.
Very good. That is correct. What about adding 1 to the entire function?
We can identify that the 1 added to the entire function is going to result in a vertical translation up 1 unit, right?
That is correct again. I think you're getting the hang of this topic. Now we know that our graph of the equation y equals 4 to the power of x is going to be translated 2 units to the left and 1 unit up to give us the new graph of the equation y equals 4 to the power of x plus 2 plus 1. We will finish this problem by taking a point on our original graph of y equals 4 to the power of x, for example, the point 0, 1, and translating it 2 units to the left and 1 unit up like so. Giving us the new point of -2, 2, a new graph, and the final solution to our problem. We can solve this problem outside of ALEKS as well. First, we will graph the original equation without the transformations, y equals 4 to the power of x. We can do this by making a table and plugging in possible values for x and recording the values we get for y. Let's do this for the x values of -2, -1, 0, 1, and 2. When we plug in these values for x, we get the values 1/16, 1/4, 1, 4, and 16 for the corresponding y values. Next, we will plot these points and draw our graph. Now, let's make a table of the values for our graph after the transformations are applied. Y equals 4 to the power of x plus 2 plus 1. We can start with the x and y values of our original equation and apply our previously identified transformations. In this case, we identified a horizontal translation to the left of 2 units and a vertical translation up of 1 unit. Horizontal translations affect our x values, so we know that 2 units are going to be applied to our x values in some manner. Identifying that it is a horizontal translation to the left tells us that we are going to have to subtract the value of 2 units from the x values to get the graph to shift to the left. Vertical translations affect our y values, so we know that 1 unit is going to be applied to our original y values in some manner. Identifying that it is a vertical translation up tells us that we are going to have to add the value of 1 unit to the y values to get the graph to shift upwards. These transformations give us a new set of points for our new graph. Let's plot these new points and look at the graph for y equals 4 to the power of x plus 2 plus 1. Comparing the graph of y equals 4 to the power of x to the graph of 4 to the power of x plus 2 plus 1, we can identify each of the points that we plotted in the first graph have shifted 2 units to the left and 1 unit up. Take the point 0, 1 for example. We can now find it on the new graph at -2, 2, 2 units to the left and 1 unit up from where it was located before the transformations.
Let me make sure I understand everything. When we add or subtract a real number on the inside of a function, usually next to the x within the parentheses, it results in a horizontal translation. When we add or subtract a number to the entire function, it results in a vertical translation.
You've got it!